Welcome to Science to Sleep By. Tonight, as the world around you slows down, as the lights dim, and the noise of the day finally fades, we're going to take a gentle journey far beyond Earth, not to places of comfort or familiarity, but to worlds so strange, so extreme. They stretch the imagination of even the most seasoned astronomers. These are exoplanet planets that orbit distant stars, far outside our solar system. Some are burning hotter than any furnace we could build on Earth. Others are frozen in darkness, drifting silently through space. Some are crushed by gravity, while others are wrapped in endless oceans or skies made of glass. Tonight's story is not meant to rush you. There's nothing to solve, nothing to remember. Just slow images, soft explanations, and the quiet wonder of the cosmos. So take a deep breath. Let your shoulders relax, and as your eyes grow heavy, let's drift together to the most extreme exoplanet we've ever found. Far beyond our solar system, there are worlds so intensely hot that the very idea of a solid surface begins to lose its meaning. These are the worlds of fire exoplanet that orbit dangerously close to their parent stars, locked in an eternal embrace of heat, radiation, and gravity. As we slowly explore them, they reveal a universe that is far more extreme and far more patient than anything we experience on Earth. On these planets, distance is everything. While Earth sits at a comfortable remove from the sun, allowing liquid water and gentle seasons, many exoplanets circle their stars at distances that would place them deep inside the orbit of Mercury. Their years last only a few Earth days, sometimes even just a few hours. The star looms impossibly large in their sky, filling it with blinding light and relentless warmth. Over millions of years, this constant exposure strips away atmospheres, melts crusts, and reshapes the planet into something almost unrecognizable. One of the most famous of these fiery worlds is WASP-12b. A gas giant so close to its star that it is being stretched and distorted by gravity. Its atmosphere is superheated to temperatures exceeding 4,000 degrees Fahrenheit, hot enough to tear molecules apart. At such extremes, the familiar rules of chemistry begin to soften. Gases glow, atoms move freely. The planet itself appears swollen, as if slowly evaporating into space. From a distance, it is quiet and serene, yet unimaginably violent in its physics. Even more haunting are planets like WASP-76b, a world where heat creates a truly alien weather system. On the day side, temperatures are high enough to vaporize iron. That iron gas is then carried by powerful winds toward the cooler night side, where it condenses and falls as molten metal rain. There is no thunder, no lightning as we know it, only the slow, silent descent of liquid iron through an atmosphere glowing with heat. It is a reminder that rain is not always gentle, and clouds are not always soft. Despite their violence, these planets are not chaotic. Everything happens slowly, methodically, governed by gravity and thermodynamics. The star burns steadily. The planet orbits faithfully. The heat rises and falls in predictable patterns. In this way, even the most extreme worlds participate in the universe's calm rhythm. There is no urgency in space, only time unfolding at its own pace. Many of these fiery exoplanets are tidally locked, meaning one side permanently faces the star, while the other remains in endless night. The day side is a realm of constant noon, where temperatures never drop and shadows never move. Rock may exist, not as solid ground, but as vast oceans of magma, glowing faintly red beneath a hazy atmosphere. The night side, by contrast, may be comparatively cool, though still hostile by Earth standards. Between these two extremes lies a thin twilight band, a narrow region where heat and darkness meet in balance. In this twilight zone, winds can reach extraordinary speeds as the planet attempts to redistribute heat from day to night. Entire atmospheres are in motion, flowing like a slow cosmic river around the globe. These winds do not howl in sound, because sound requires ears, air, and presence. Instead, they move silently, shaping clouds and temperatures over centuries, not moments. It is a form of weather that feels almost meditative in its scale. Rocky lava worlds take this idea even further. On planets like 55 Cancri, The surface may be dominated by global magma oceans. There are no continents, no stable ground to stand on. The crust repeatedly melts and reforms as the planet flexes under gravitational stress. Volcanoes may erupt continuously, not in dramatic explosions, but as steady outpourings of molten rock, glowing softly beneath a star-filled sky. Light behaves differently on these planets. Heat distorts atmospheres, bending starlight and creating permanent shimmering horizons. The sky may glow faintly from the heat itself, even on the night side. Stars would not twinkle as they do on Earth, but smear into elongated shapes through thick, turbulent air. If one could float above such a world, the view would be hypnotic rather than frightening slow-motion fire, endless and quiet. These worlds of fire also teach astronomers important lessons about planetary survival. They show how atmospheres are lost, how planets migrate inward after formation, and how stars influence the fate of the worlds around them. Many scientists believe that some of these planets did not form close to their stars at all. Instead, they were born farther out, in cooler regions, and gradually spiraled inward over billions of years. Their present state is not sudden destruction, but the final chapter of a very long story. There is something strangely comforting in that idea. Even destruction in the universe is not abrupt. It is patient. A planet does not burn away overnight. It changes slowly, molecule by molecule, orbit by orbit. As if the universe is giving it all the time it needs to become what it is meant to be. For those of us listening from Earth, safe beneath a calm atmosphere, these fiery exoplanets serve as a quiet contrast. They remind us how rare our conditions are, and how gentle our world truly is. Our oceans are cool. Our rain is water, not metal. Our ground is solid beneath our feet. Yet we are made of the same atoms, governed by the same laws, connected to these distant worlds by physics and starlight. As you rest now, it can be soothing to imagine these planets continuing their endless orbits, glowing softly in the darkness of space. No alarms, no deadlines, just heat, gravity, and time moving forward together. The universe holds even its most extreme creations with calm consistency, and in that vast, fiery stillness, there is room for rest. Let your thoughts drift like a planet circling its star, steady and unhurried. These worlds of fire will keep burning long after we fall asleep, quietly reminding us that even in the most intense conditions, the cosmos remains beautifully, endlessly calm. Far from the warmth of stars and the familiar glow of daylight lie some of the coldest, quietest worlds ever discovered. These are the realms of frozen darkness, exoplanet that exist in deep cold or eternal night, where heat is scarce and time seems to slow almost to stillness. In these distant places, the universe reveals a softer, quieter kind of extremity, one defined not by fire, but by silence. Some of these worlds orbit their stars at tremendous distances. Their orbits are so wide that a single year can last thousands of Earth years. From the planet's surface, the parent star would appear not as a blazing sun, but as a distant point of light, barely brighter than the surrounding stars. The little warmth it provides is precious, and over billions of years, that scarcity shapes everything. Ice becomes the dominant force, slowly sculpting landscapes under a sky that rarely changes. On these distant planets, temperatures fall so low that even gases freeze solid. Nitrogen, oxygen, and carbon dioxide from thick layers of ice across the surface. The ground becomes a vast, frozen plain, marked by slow-moving glaciers that creep forward over geological time. There are no seasons in the way we know them, only subtle shifts in light that occur over centuries. The planet breathes slowly, almost imperceptibly. Even more mysterious are the rogue planets, worlds that drift through the galaxy without any star at all. These planets were likely born in planetary systems long ago, only to be flung outward by gravitational encounters with larger worlds. Once freed from their stars, they began an endless journey through interstellar space, carrying with them only the faint warmth left over from their formation and the quiet heat produced deep within their cores. On a rogue planet, there is no sunrise and no sunset. The sky is permanently black, filled with distant stars that do not rise or set. There is no day to mark time, no seasons to measure change. Darkness is not frightening here, it is simply the natural state of things. The planet moves silently through the galaxy, unseen, untouched, and unconcerned. Despite the cold, these worlds are not entirely dead. Beneath thick shells of ice, internal heat can persist for billions of years. Radioactive elements in the planet's core release energy slowly, warming deep underground layers. In some cases, this heat may melt subsurface oceans, hidden beneath miles of frozen crust. These secret seas are sealed away from space, dark and quiet, yet potentially stable for eons. If you could descend into one of these hidden oceans, there would be no waves, no wind, no sunlight. The water would be heavy and still, warmed gently from below. Chemical reactions near the core could provide energy, much like the hydrothermal vents at the bottom of Earth's oceans. Life, if it exists there, would not need light. It would exist in slow motion, shaped by patience rather than urgency. Frozen darkness also defines planets that are tidally locked from their stars. On these worlds, one side permanently faces away from the star, trapped in eternal night. While the day side may receive some warmth, the night side becomes a frozen wasteland, where temperatures plunge and ice builds endlessly. Atmospheres can freeze out and collapse onto the surface, forming thick glaciers of air itself. The transition between light and darkness on such planets is gradual and vast. Heat moves slowly across the planet, carried by sluggish winds and slow atmospheric circulation. Time stretches. Change happens so gently that it feels almost suspended. These worlds do not rush toward equilibrium, they drift toward it. The sky on a frozen exoplanet would feel enormous. With little atmosphere to scatter light, stars would appear sharp and steady, unblinking. The Milky Way would stretch across the sky like a frozen river of light. There would be no clouds racing overhead, no storms breaking the silence. Just stillness, broken only by the slow creaking of ice shifting beneath itself over centuries. Scientists study these worlds carefully, not because they expect comfort there, but because frozen planets preserve history. Cold slows chemical reactions, locking information into ice and rock. These planets act like time capsules, preserving conditions from the early days of planetary formation. By studying them, astronomers learn how planets evolve, migrate, and sometimes survive extreme loss. There is also something deeply calming about these frozen worlds. They exist beyond urgency, beyond drama. Their stories unfold over billions of years, not moments. A crack in the ice may take centuries to widen. A glacier may take 1,000,000 years to move a single mile. In a universe that often feels overwhelming, these planets remind us that stillness is also a fundamental force. From Earth, wrapped in warmth and air, it can be soothing to imagine these distant, frozen places. They do not ask anything of us. They do not change suddenly or demand attention. They simply exist, quietly orbiting or drifting, held together by gravity and time. As you lie here now, allowing your breathing to slow, picture one of these worlds moving gently through the dark. There is no sound, no movement that needs watching, just the soft certainty of a planet continuing on its path. Frozen darkness is not emptiness, it is rest, stretched across the vast canvas of space. And as sleep draws nearer, let your thoughts become like these distant planets, cool, calm, and unhurried, floating peacefully through the universe, carried by forces older and quieter than any dream. In the quiet reaches of the universe, there are planets where gravity is not a gentle companion, but a powerful, ever-present force. These are the worlds where gravity has grown wild, where mass is packed so tightly that even the familiar idea of weight begins to feel abstract. On these planets, gravity shapes everything from the air above to the very structure of matter itself, and it does so slowly, patiently, without drama. Many of these planets are known as super-Earths. They are not like the gas giants of our solar system, nor are they small, rocky worlds like Earth or Mars. Instead, they exist in a middle ground, with masses several times greater than Earth's, compressed into a relatively small volume. This combination creates surface gravity so strong that it fundamentally changes how the planet behaves. If you could stand on such a world, your body would feel heavier with each breath, as though the planet itself were gently pulling you closer, asking you to rest against it. On a high-gravity planet, mountains struggle to rise. On Earth, tectonic forces can push rock skyward, forming towering peaks. But when gravity is stronger, rock cannot support itself as easily. Mountains become shorter and broader, spreading outward instead of upward. Landscapes flatten, not because they are calm, but because gravity refuses to allow excess height. The planet smooths itself over time, creating wide plains and shallow basins that stretch endlessly beneath the dense sky. The atmosphere on such a world clings tightly to the surface. Gases that would easily escape a smaller planet are held firmly in place. This creates thick, heavy air, pressing down continuously. Clouds move more slowly, weighed down by gravity. Weather systems unfold at a deliberate pace, forming and dissolving over long periods rather than violent bursts. Even storms feel muted, not because they lack power, but because gravity restrains their motion. Breathing in such an atmosphere would feel different. Each inhale would be rich and heavy, filling the lungs with effort. Sound would travel farther and slower through dense air, creating a world where silence is rare, but noise is softened. Every movement, every vibration, would feel dampened, as if the planet itself were absorbing energy and refusing to let it rush. Deep beneath the surface, gravity continues its quiet work. Immense pressure builds as layers of rock stack atop one another. Minerals are forced into new structures, forming exotic materials unknown on Earth. Atoms are pushed closer together, altering how they bond and behave. The planet's interior becomes a laboratory where physics experiments run for billions of years. Unnoticed and uninterrupted, some super-dense exoplanet may be composed largely of iron or other heavy elements, remnants of massive collisions during their formation. These worlds are incredibly compact, with gravity so intense that even standing still would be exhausting. Time itself might feel different there, not because it truly changes, but because movement becomes deliberate, slow, and intentional. Every step would carry weight, both literal and emotional. Yet even on these crushing worlds, there is balance. Gravity does not seek destruction, it seeks stability. Over time, the planet settles into equilibrium, with internal heat flowing steadily outward, and the surface adjusting to accommodate the force pressing inward. Volcanoes may still exist, but eruptions are likely slower and more controlled, with lava spreading thickly rather than spraying violently. Everything moves with purpose, guided by the planet's immense pull. Some of these high-gravity planets orbit close to their stars, adding heat to the pressure they already endure. In such environments, rock may behave like a fluid, slowly flowing under its own weight. The surface might shift and reform over thousands of years, smoothing itself again and again. It is a planet constantly reshaping itself, not through chaos, but through quiet persistence. Astronomers are deeply fascinated by these worlds because they challenge our understanding of habitability. Life on Earth evolved under a specific gravitational condition. Muscles, bones, circulation all are tuned to this delicate balance. On a high-gravity world, life, if it exists, would have to adapt in profound ways. Organisms might be shorter, sturdier, closer to the ground. Growth would be slow. Energy would be conserved carefully. Nothing would be wasted. In some ways, these planets feel deeply restful in concept. There is no rushing upward, no dramatic leaps or soaring heights. Everything is grounded. Everything is held. Gravity ensures that nothing drifts far from home. It is a constant presence, like a deep, steady heartbeat beneath the planet's surface. From far away, these worlds appear calm and unremarkable, small points of light crossing in front of distant stars. But within that tiny shadow lies a realm of immense force, quietly shaping matter and time. Gravity does not announce itself. It does not flash or roar. It simply works, endlessly, faithfully, pulling everything into place. As you lie here now, letting your body sink into rest, you are also feeling gravity's gentle touch. On Earth, It is just strong enough to hold you comfortably, to keep you grounded without strain. Thinking of these distant, heavy worlds can make our own gravity feel kind, almost tender by comparison. Imagine one of these planets turning slowly in space, wrapped in thick air, its surface pressed smooth by immense weight. Nothing is hurried there. Change takes time. Movement is meaningful. It is a world that invites stillness, not because it demands it, but because it makes rushing unnecessary. And as sleep draws closer, let your thoughts become heavier in the best way, settling, grounding, relaxing like matter finding its place on a planet where gravity has gone wild. And peace comes from simply being held, far beyond the familiar blue of Earth's oceans. There are planets where water exists on a scale almost impossible to imagine. These are the ocean worlds, exoplanet where water is not a feature, but the defining substance, stretching across the entire globe in depths that reach hundreds or even thousands of miles. On these planets, land as we know it may not exist at all. There are no continents to divide the seas, no shores to mark beginnings or endings, only an endless, planet-wide ocean quietly moving beneath distant stars. Many of these water-rich worlds are believed to have formed far from their stars, where ice was abundant during the early days of planetary formation. Over time, gravitational interactions pulled them inward, warming their surfaces and melting the ice into vast, global oceans. What remains is a world wrapped completely in water, with no visible rock at the surface. From space, such a planet would appear smooth and dark, reflecting starlight softly, like a polished mirror drifting through the void. On these ocean planets, the surface water may feel calm and deceptively familiar at first. Waves roll slowly under gentle winds, unbroken by coastlines or mountains. Storms have nothing to crash into, so they spread wide instead of tall, moving across the planet like slow, breathing patterns. There is a sense of openness here, an uninterrupted horizon that curves gently in every direction, reminding you that this is a world without edges. As you descend beneath the surface, the ocean deepens in a way Earth's seas never do. Sunlight fades quickly, absorbed by the thick layers of water. A few hundred feet down, the world grows dim. A few miles down, darkness becomes complete. Yet the ocean continues, layer after layer, pressing down with increasing weight. Pressure builds steadily, quietly, without any sudden change, until water itself begins to behave differently. At great depths, the familiar liquid state of water transforms. Under immense pressure, water molecules rearrange into exotic forms of ice-solid structures that exist not because of cold, but because of force. This hot ice forms dense barriers deep beneath the ocean, separating the liquid water above from whatever lies below. These layers are smooth, silent, and stable, creating a kind of frozen foundation beneath the sea. Below the ice, there may be more water, warmed by the planet's internal heat. This hidden ocean would be completely sealed away, untouched by surface conditions or starlight. It would exist in total darkness, warmed from below, stable for billions of years. In such environments, chemistry proceeds slowly and steadily, creating conditions that some scientists believe could be friendly to life. Life, if it exists on these ocean worlds, would be nothing like what we know on land. There would be no trees, no birds, no familiar rhythms of day and night near the surface. Instead, life would adapt to pressure, darkness, and patience. Energy might come from chemical reactions near the planet's core, similar to the hydrothermal vents on Earth's ocean floor. Creatures there would move slowly, conserving energy, drifting more than swimming. Even without life, these oceans are fascinating in their own right. Water is an extraordinary substance, capable of storing heat, dissolving chemicals, and moderating planetary climates. On an ocean planet, water acts as a massive thermal blanket, smoothing out temperature extremes and creating a remarkably stable environment over long periods of time. The planet's climate would change gently, without sudden shifts, unfolding over millions of years. The sky above an ocean world would feel immense and open. With no land to break the view, clouds would stretch endlessly, forming broad, layered patterns. Rain would fall frequently, but gently merging seamlessly with the ocean below. There is no runoff, no rivers, carving paths through stone. Water simply returns to itself, completing a quiet, continuous cycle. Time feels different on a world of endless water. Without solid landmarks, change is measured not in distance, but in depth and temperature. Currents move slowly, guided by the planet's rotation and internal heat. A single current may take centuries to complete its path around the globe. Nothing rushes. Everything flows. Scientists are drawn to these ocean planets because they challenge long-held assumptions about habitability. For years, Earth-like conditions were considered the ideal, but these worlds suggest that stability and abundance may matter more than familiarity. A planet covered in water may lack land, but it also avoids many of the extremes that plague rocky worlds. There are no deserts, no frozen continents, no volcanic wastelands exposed to the sky. From Earth, thinking about these worlds can be deeply calming. Water is associated with rest, with floating, with release. Imagining an entire planet devoted to water amplifies that feeling. It is a world where nothing resists gravity harshly, where surfaces yield and adapt, where motion is smooth and unforced. As you relax now, you can picture one of these ocean planets turning slowly beneath its star, its surface rippling gently in endless patterns. There is no urgency in its movement, no sharp edges or sudden changes. Just water, depth, and time working together. In the vast diversity of the universe, these ocean worlds remind us that life and beauty do not require solid ground. They show us that even in the absence of land, a planet can be whole, complete, and quietly alive with possibility. And as sleep approaches, let your thoughts become like water on these distant worlds, deep, unbroken, and at peace. Above many distant exoplanets, the sky is not a place of comfort or familiarity. These are strange skies, atmospheres shaped by extreme heat, crushing pressure, and exotic chemistry, where clouds are not made of water and rain is not something you could ever touch. Yet even in their strangeness, these skies follow quiet, unbreakable rules, unfolding slowly beneath distant stars. On Earth, our sky feels gentle and protective, a thin blue layer that softens sunlight and carries weather calmly around the globe. On extreme exoplanet, atmospheres can be vastly thicker, hotter, and more dynamic. Some are so dense that standing beneath them would feel like being submerged in a deep ocean of air. Others are thin and fragile, slowly escaping into space under the pull of a nearby star. Each atmosphere tells a long story about the planet beneath it. On some of the hottest exoplanets, temperatures are so high that familiar substances become unrecognizable. Rocks vaporize. Metals turn into gas. In these skies, clouds can form from minerals rather than water. Silicates, the same materials that make up sand and glass on Earth, can evaporate into the atmosphere and later condense into tiny solid particles. These particles drift slowly through the sky, forming hazy layers that glow faintly under starlight. On worlds like HD 189733b, winds race across the planet at thousands of miles per hour, carrying these silicate particles sideways through the air. What falls from the sky there is not rain, but microscopic shards of glass. The idea sounds violent, yet the process itself is smooth and continuous, driven by steady winds and temperature differences. The planet does not rage. It simply circulates its atmosphere, endlessly and quietly. Some strange skies are filled with toxic chemistry. Thick clouds of sulfur compounds, ammonia, and methane can dominate the atmosphere, tinting the sky yellow, orange, or deep red. These gases absorb and scatter light differently, creating skies that glow even at night. The horizon may blur into a constant haze, with no clear distinction between ground and sky. Everything feels softened, muted, wrapped in a chemical fog that never lifts. On cooler exoplanets, clouds may form from substances like ammonia or even salt. These clouds drift slowly, layering the atmosphere like sheets of silk. Lightning may flicker deep within them, not because of water droplets colliding, but because of charged particles interacting in unfamiliar ways. The light from these storms would be dim and distant, flashing gently through thick atmospheric layers. Some planets possess skies so hot that molecules cannot remain intact. Intense radiation from nearby stars tears atoms apart, creating glowing ionized layers high above the surface. These upper atmospheres shine faintly in ultraviolet light, slowly leaking into space. Over billions of years, the planet loses part of itself, not violently, but as a steady exhale into the void. Tidally locked planets create especially dramatic skies. On the day side, intense heat drives powerful updrafts as air expands and rises. On the night side, cold causes air to sink and condense. Between them, enormous atmospheric rivers flow continuously, redistributing heat around the planet. These winds do not come and go with seasons. They are permanent features, as reliable as the planet's orbit. In these skies, clouds may never dissipate or reform. They exist in stable bands, circling the planet endlessly. From space, the planet appears striped or marbled, its atmosphere painted with slow-moving patterns that change only over years or decades. It is weather without urgency, motion without chaos. The colors of these strange skies would feel unfamiliar to human eyes. Without Earth-like scattering, the sky might appear black even during the day, or glowing orange beneath a white-hot star. Sunsets, if they can be called that, would not be moments but regions-long transitions as one moves across the surface, rather than through time. Light behaves differently when filtered through exotic gases and thick haze. Astronomers study these atmospheres by analyzing starlight as it passes through them. Each gas leaves a faint signature, a tiny fingerprint that reveals its presence. From across light years of space, scientists can tell whether a sky contains water vapor, carbon monoxide, sodium, or clouds of unknown composition. It is a slow, patient science, built on careful observation and quiet interpretation. These strange skies are more than curiosities. They shape the fate of the planets below. Atmospheres regulate temperature, protect surfaces from radiation, and influence geological processes. A sky that traps heat can turn a world into a furnace. A sky that escapes can leave a planet cold and bare. Over time, the sky and the planet become inseparable, evolving together. There is something deeply calming in imagining these alien atmospheres continuing their slow circulation, long after we fall asleep. Winds flow without sound. Clouds form without witnesses. Chemical reactions proceed quietly, molecule by molecule. The planet does not know. It is strange. It simply exists, following the same physical laws that guide every sky in the universe. Thinking of these skies can also make our own feel comforting and familiar. The blue above us, the soft movement of clouds, the gentle fall of rain, all of it is rare and precious. Yet the universe is not unkind to its other worlds. It gives each planet the sky it can sustain, shaped by its history and place among the stars.